Hello, students. I'm going to take some time today to go over what we went through in class yesterday. I'm going to use a clean copy of the relative dating worksheet, the What's Up activity. You can find the actual worksheet that I used in class as an attachment to yesterday's assignment. So if you open up Google Classroom, go to classwork, look under January 4th through the 8th, and if you look on Thursday, you can see that I went ahead and attached that in there. It should be correct. I told it to include the annotations. We will see if it did that, but just take a look and see what you can find in there. Okay. So your makeup work for today is to watch this video and then finish part 2 of the What's Up activity. Specifically, we are doing questions 1, 2, 3, and 4. So right now, I'm going to go over with you what we went over in class yesterday. Okay, so in class yesterday, we spent quite a bit of time going back through and just kind of looking at what is already present. This is from Tuesday in class that we went over this. And I told you that you need to make sure that you know all of these principles. Now, you don't have to be able to recite them or to completely write them down again, but you do need to be able to apply them. And you also need to know how to go through and tell what the abbreviations are, because we don't want to write principle of superposition or principle of original horizontality all of the time. We actually just want to be able to put in an abbreviation. So for superposition, we use SP. For original horizontality, we use OH. For principle of faunal succession, which right now we don't use that a whole lot. We'll talk about faunal succession more later next week, but that's probably not something you're going to see very much right now. But we would still use FS. And then principle of cross-cutting relations, we actually use kind of an incorrect abbreviation. We use CCR, even though both of the C's are in one word. And then for principle of inclusion, we use INCL, so for inclusion. Okay, so here are the abbreviations. You should kind of at least write those down and know what those are, because those are the abbreviations that you'll be expected to use. Okay, so as we move through here, we started talking about this very first set of information on Tuesday. And so I'll run through that again with you right now. So for this one, this is very basic, and we're just going to use the principle of superposition for this one. Okay. What's really important about that? Well, what's really quite important about that is that we are looking specifically at this with sedimentary rocks. Okay, superposition works very well with sedimentary rocks, doesn't work all that well with other types of rocks. Okay, when we're taking a look here, this will be our oldest layer. This will be our youngest layer. The idea behind that is that layer A was put down first, layer B was put down on top of that, layer C was put down on top of that, and then layer D was put down on top of that. Very simple setup right here. Okay? As we're sliding through here, this gives you some more information that you're probably going to want to go back and take a look at. So we've got all of this talking about sedimentary rocks. Okay, so if the rocks are folded, the rocks had to exist before the folding happened. So if the rocks are folded, the rocks were there and then the folding occurred. So the folding is younger than the rocks affected. All right, so when you're looking at this one, if we went through, this is probably not the best thing for me to do, to actually try to write with the draw tool, but we're going to give it a try here. If we go through here, then we're going to say that A is the oldest, B is next, C is after that, then we've got D, followed by E and F. Okay, so somewhere between or after D, so right about here, so somewhere in that area, there's this unconformity. So you read about different kinds of unconformities. Probably what has happened here is some kind of weathering and erosion. Okay, so this is probably an example of weathering and erosion. All right, so that took off the top layer here, and then at some later point in time, E was deposited on top. All right. The next group that we're going to talk about, or the next thing that we're going to talk about, will be igneous rocks. So here is our igneous rocks part. So they are formed by the solidification of a liquid magma. And usually when we're talking about igneous rocks in this context, we're tending to talk about liquid magma solidifying. So we're talking about what's happening underneath the surface. Sometimes that'll come to the surface, become lava, but generally what we're talking about is inside the earth, where you have maybe a magma chamber that solidifies. Okay, and it does point out here in your reading that this can be from pre-existing rocks, or it can be poured out onto the surface of the rocks, of the earth, sorry. All right, so you can take a look through there. And we had a couple of questions about contact metamorphism yesterday. Here is some information in your reading about that. So intrusive rocks produce contact metamorphism along their contacts with the older rocks they intrude into. Lava flows may also cause contact metamorphism with the older rocks they lie upon. The way that we talked about that in class is like if you take some kind of not very strong plastic container. You take, I think the example that somebody suggested that we use was like a lunch meat container. And so if you put that on the cabinet or in the sink would probably be a better idea, and you pour boiling water into it, what's going to happen? Well, it's not going to melt completely, but it's probably going to kind of like bend or wrinkle up or become misshapen. Same thing sometimes happens when you put different kinds of plastic into the dishwasher and it gets a little bit hot. It comes out and like the lid's warped and it won't fit anymore, or kind of things like that. That would, in effect, be kind of a way that you could think of contact metamorphism, because in those instances, the older rock, which we're saying would be our plastic container, is touched by something that is more recent. It's coming into contact with it now, and it's hot. And so it doesn't completely melt the container, but it does change the container. So that's kind of the same idea here of this contact metamorphism. So there's some kind of change that has happened close to where this hot new magma has intruded. All right, moving on. Metamorphic rock is our next part, and so you'll take a look through here. They are pre-existing rocks that have been changed by a lot of heat and pressure in the region. So that's what metamorphism is. Okay, they are always older than the sedimentary rocks deposited above them, or they're older than the igneous rocks that may intrude them. All right, so that's kind of the big idea on the metamorphic rocks. Okay, now for the keys, these are 3 different groupings of rocks. You don't have to learn what they are specifically. You can just always go back to the key. But once you use the keys enough, you'll possibly learn what they are anyway. So here are the sedimentary rocks. Here are the igneous rocks. Here are the metamorphic rocks. And then you're also going to need to know what these special features are. So why do you have some kind of weird looking line? Well, those weird looking lines are all going to tell a story. So you need to know what a fault is. We've already talked about unconformities a little bit. We just talked about contact metamorphism. So make sure that you're paying attention to these special features that you see. Your assignment for Tuesday was to finish up this part 1 on your own. So you should have all of these questions finished. I'm taking a look at them and really just kind of giving you a basic, yeah, you did that, fine, no, you didn't, and not really going through and grading them. We'll go over them in class one day next week. And then what we're working on today is this part right here. So we're going to work on part 2. Okay. So this is where we're going to spend most of our time, or really almost all of the rest of our time today. We'll be going through this information. So in class, we kind of went through and tried to figure out, okay, so what would be the order of this? And so in looking at the order, I would like you to pause for just a second and try to put these in the order that you think they're in. Okay. Here is what you should have gotten. You may or may not have this as your answer. If you do not have it as your answer, then go ahead and go back through and correct it. You may also have the question of, well, why is B younger than A? Isn't A in part of B? No, not really. B formed over top of A. And remember that anytime that you're looking at an intrusion, and that's what this is, anytime you're looking at an intrusion, that intrusion can run along the surface of the Earth. So at this point in time, what you see here is that this was the surface when A cross-cut C, E, and D. So right here you would have some lava. And this right here is our hint. If B had been present, then A would have gone ahead and cut to the surface, because this is just basically a sedimentary rock. And so this hotter lava, or sorry, this hotter magma right here would have been able to cut through and go to the surface. Since that didn't happen, and this happened instead, we know that this had to have been the surface, and then B was deposited later on. Okay, so there are a couple of things that we can do with this at this point in time. One of the first things that we can do is go ahead and put in some different laws. So what laws are present? How do we know that this is what happened? And then once we put those laws in, we can start to write a history of what's going on within this cross section of the Earth. So I'm going to draw little kind of carrots here, and those will help me to see that I'm talking about the relationship between these two layers. I'm going to draw another one there. So that's a relationship between those two layers. Draw another one there, relationship there, and then relationship there. Then I'll go back and we're going to put in some laws. So we're saying that E is younger than C. What law do you think would apply there? If you said superposition, you would be correct. D is younger than E. What law applies there? Again, superposition would be correct. What about A cutting through D? This would be cross-cutting relations. And then the last one here, B is formed on top of all the rest. You're right, that would be superposition. So We have all of our laws attached now to the groupings that we have. So now we can take just a second and we can try to write out a history. Let me put a note in here for you about this intrusion. And let's just say that A is an intrusion. That's going to be cross-cutting relations. The intrusion cut through C, E, and D, then ran along the ground. So that's the information that I gave you earlier on, but I gave it to the class yesterday also in a note, just so that you can see it. All right. So let's go ahead now and start writing our history. So the way that I would do this is I would start at the oldest. So layer C was deposited first, followed by layers E, which is limestone, and D, which is sandstone. Intrusion A cut through C, E, and D. Then layer B, which is shale, was formed on top of A and D. So this is a basic history of what happened here within this cross section of the Earth, of a rock group. This gets a little bit more difficult as you get more things involved, but it's a pretty good way to start out. So let's move on down to layer 2. All right, so take just a second and put in what you think would be the rocks from oldest to youngest, and go ahead this time and write out to the side what you think would be the laws. Remember to put the little carets in. They're not that hard to draw, and they are super helpful in making sure that you have the law beside the correct place. Okay, here are your answers. You can check and see if you got those correct. You can pause for just a second if you'd like. And now let's go through and discuss, why is this the actual case? Well, first of all, B is our intrusion. We know that B is the intrusion because we have this zone of contact metamorphism right there. Okay, and so we can see that. Here's our zone of contact metamorphism, and here's another. So we know that E was likely in place first, and then B occurred later. So this is the intrusion into E that existed. We can also see right here, and I know the yellow's not super bright, but it gives us a little different color. This gives us kind of a glimpse into the information all the way across through here, because this is an unconformity. So we know that both of these layers had to exist before C, which is a sedimentary rock, this is limestone, was put in on top of it. So then D, which is I think sandstone, and A, which is shale, all are put in on top. So now what I would like you to do is see if you can write a history of figure 2. Try to do that on your own. Okay, so here is the information that I came up with. Layer E, which is schist, was formed first, then layer B, which was basalt, cut through the schist layer. Then weathering and erosion resulted in an unconformity. Finally, layers D, sandstone, and A, siltstone formed on top of E and B. And C. I think I left C out there. C is limestone, by the way. So go in and fix, make sure that you fix that to include C. That's a mistake that I made in class yesterday. Okay, so take a look at this. Make sure that you understand it. See if you can kind of figure out the whys of why all of that went on. And then let's go ahead and go down here to figure 3. Figure 3 is a little bit more complex. What's the order that you think this happened in? Okay, so here is the order. C is the oldest, followed by A, and then followed by B. So we see again, right here, that we have a zone of contact metamorphism. So that's going to tell us that this layer, which is layer C, C had to be present first. A is an intrusion. So we can type that in here. A is an intrusion. That doesn't show up at all, does it? So A is an intrusion into C, and then B is an intrusion that cut through all of the rest. So if you are putting this information in here as well, what are the laws? All of the laws here are actually the same. Cross-cutting relations. Okay, so no superposition in this case. All right, now, what I would like you to do on your own is to go ahead and take a look at figure 4 and work on this on your own. This is your kind of finish it up from class. There are a couple of things that I want to show you as we run through this. So one thing is B is a fault. And so that fault would continue on down through here or potentially would. And you would have G here below C. So just remember that that's how this part would go. Over here, E is also a fault. And so that fault line is going to continue down through there. And so if you've got A here, you can see that A continues all the way across. There's limestone, limestone, limestone. That's all layer A across through there. E is the fault and B is the fault. So below A, you're going to have C. And below C, you would have G that had moved down as well. Okay, so just kind of remember that there are those parts that exist here as well. All right, so work on figure 4. And for figure 4, you would work on doing the order. And then you would work on doing the laws. And then you would work on writing the history. Grading on this is basically going to be, did you do it completely and did you do it with at least some reasonable correctness? I'm also going to check to make sure that you have all the annotations in because you need these notes. So this is pretty much just notes, and also I want to see you do some practice. I'm not going to penalize you too much if you don't do the practice correctly. We'll go over it next week. Right now, I want you to be doing the stuff and learning as you go. All right, that's it. That's all. Hope you have a wonderful weekend, and I'll see you in class on Tuesday.